All right, for number 33, we're not actually given the initial amount of bacteria, and A is always the initial amount. They gave us that after 3 hours we have 100, and after 5 hours we have 400. So this one has to be solved differently because they didn't give us the data point for A. All right, there's the model. They gave us T and Y, but not the initial condition. So we have to solve this differently. All right, so what we're going to do is I'll write the equation for each of these. So Y is 100 AE B to the 3. That's the first one. And 400 equals AE B times 5. Okay. So if you notice, we have 2 equations and 2 unknowns, so we can actually solve this for A. So the idea is you want to isolate each of these equations for A, and then set A equal. All right, so for me to solve this one for A, I have to divide off the e to the 3b. I'm just change the order of that. And then for this one, to isolate the A, I have to divide this to the other side. All right, so what I did was I isolated both of them for A. So this is the same A because it's the same problem. So now what you can do is you set, since this is both A, since these are both equal, then these are both equal. Okay, so now I'm going to set this equal. All right, now I'm going to cross multiply this up. I'm going to divide by 100 to both sides. Okay, I'm going to, let's see here. I'm going to divide by e to the 3b. And if you don't catch why I'm doing that, you'll catch in a second. So this divided by this means you're going to subtract this. All right, now I'm going to take the ln of both sides. So if you wanted to back way up here, you could have just brought the 5b up here, and then that would have saved you some steps if you just brought it up and subtracted it right away. Okay, ln of e is 1. Oh, maybe let me try to put it on the same page here. Let me move it over here. All right, divide off the 2 here now. All right, so the final answer, they want to know what? How many bacteria will there be after 6 hours? Oh, you have to make the model and then use it. Oh, okay. Did I change the letter somewhere? No, I didn't. We're solving for B. Okay, clear. So ln for close parenthesis. Make sure you close the parenthesis there. Divided by 2. So that's 0.693147. And this problem is long. I'm going to have to... All right, let me move that over. Okay, so then you can go back to either one of these equations because you have B, so you can solve for A. So let's say you pick the first one. Doesn't matter, they'll give you the same answer. All right, now I'm going to put the B in there. You know what, let me isolate A first. So A is going to be 100 divided by e to the 3 times 0.693147. Alright, so we're going to do 100 divided by shift E 3 times, make sure this is all in the E, right? The parenthesis 3 times, keep that all in the parentheses, 0.693147, and close it, and then hit your equal. 12.5. So A equals 12.5. Okay, so we're not done yet because we now have the model. So the model is y equals to 12.5 e to the b. Did we solve for b? So that was 0.693. That was the first thing we found. T. All right, this is the complete model where you have the A and the B filled in, and now you actually have to make a prediction. So now they want to know how many bacteria after 6 hours. So like when this is 6, what's Y? So last step, so you want to plug in the value of 6 for T into the model and then crunch this out. All right, let's see here if I get this lit up a little better. All right, so you're going to do 12.5 times shift E. Put all of this in the parentheses, the 0.693147 times 6. All in the parenthesis. Close the parenthesis, hit equal. All right, I'm getting 799.999, so we're going to round this up to 800 bacteria. Sometimes with this kind of stuff, they'll say 799 because if we didn't fully make the last bacteria, you know, so it just depends. The book either is going to round up, it may round down to that. With me, as long as you're in the ballpark, I'll be fine on the test. Okay, gang, I'll catch you. Bye-bye.